This is standard number 72, graphing exponential functions. All right, so let's first talk about what an exponential function is. This is the general form that we use, the y equals a times b to the x. Okay, what's important though about an exponential function is this exponent right here of x. Okay, so anytime something is raised to the x power, okay, its exponent is a variable like x, that's when we're going to have an exponential function. All right, so let's talk about two different types of exponential functions. We have exponential growth, which would look like this graph. Okay, it's starting really close to our x-axis and then it's increasing. Okay, this would be exponential growth. And then exponential decay, it's starting up high and then it's decreasing. Okay, so I like to think decay, decrease. Our graph is decreasing. All right, so let's practice graphing some. So our directions here say graph the function y equals 3 to the x power. State whether the function is exponential growth or decay. To graph these functions, we are going to use an xy table just like we did in the graphing quadratic functions. Okay, so I'm going to do my xy chart. Okay, and then in my xy chart, I'm always going to use the same values for my exponential function. So we're going to use 5 points, and we're always just going to use -2, -1, 0, 1, and 2, just so we can get a good idea of what our graph looks like. Okay, so now what I'm going to do to find my y value is I'm going to plug in my x value just like we did with graphing quadratic functions. So I'm going to use this function up here, the y equals 3 to the x, okay, and I'm going to plug in my x value. So what I'm doing is I'm saying y equals 3 to the -2 power. Okay, so that x value that I'm plugging is becoming an exponent. Okay, so you're just going to want to type this in your calculator. When you type this in your calculator, you might have a button on your calculator that looks like 3. So you do 3 and then like this caret button and a -2. Okay, so that's one way you can type it in your calculator, or your calculator might have a button that looks like this, x to the y. Okay, so the button looks something like this. So you would type in 3, then hit your x to the y button, and then your -2. Okay, so you're just going to type this in your calculator in order to get these y values. So when I put that in my calculator, I got 0.1 repeating. So 0.11111. Okay, we use that line to show repeating. Alright, so then now I'm going to plug in my -1, so I just do y equals 3 to the -1. Okay, so I'm typing in 3 to the -1 in my calculator, same way I showed you over here to do it. So when I did that, I got 0.3 repeating, so it was like 0.33333 going on forever. Okay, then I'm going to plug in 0, so y equals 3 to the 0 power, which we should remember from when we talked about exponents. Anything to the 0 power is 1, or we can type that in our calculator, 3 to the 0 power give us 1. Alright, now I need to do y equals 3 to the first, which if I type that in my calculator, I just get 3. Okay, and then very last one, y equals 3 squared, and 3 squared is going to give me 9. Okay, so now I'm going to take this, let me erase this, and we are going to plot these points on our graph just like we did when we graphed quadratics. So for -2.1, -2 we're going to go left 2. Okay, 0.1 we know we're just going to be slightly up from the x-axis, so we're going to do our best to estimate that. Okay, then -1, 0.3, we just want to go slightly higher. Okay, and then 0, 1, so 0 I'm not moving left or right any, then I go up 1. Okay, for the 0.13, so now I've graphed these 3. For the 0.13, from my origin I need to go right 1 and up 1, 2, 3, put my point, okay, and then now we need to do the very last point, the 0.29. So starting at my origin, I'm going to go right 1, 2, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're going to put a point there. And then now when we draw our graph, remember we want it to be like that curve like I showed you. So I'm going to do my best to sketch that on here. Oops. Let's try that over again. Okay, so we want it to increase up through this line. Okay, remember we put our arrows on both sides because it goes on forever. All right, so let's look at one more example. So it says graph the function y equals 1/3 x. Oh, I just realized we didn't state whether it was exponential growth or decay. So since my function is increasing, then this is going to be exponential growth. Okay, so it's starting low, it's getting up higher, so exponential growth. All right, so now we want to graph the function y equals 1/3 x. So I'm still going to create my xy chart. Okay, and I'm going to plug in the same values we did before. So -2, -1, 0, 1, and 2. Okay, so now I'm just plugging in, so I'm using the function y equals 1/3, and then for this one my exponent is -2. Okay, so when I plugged in -2, I got a +9, and then I'm going to plug into my calculator like this a -1. Okay, when I did that I got 3. I continued to plug it in, I got 1, I got 0.3 repeating, and then I got 0.1 repeating. Okay, so let's go ahead and graph this. I'm going to go -2, so left 2, and then +9, up 9. 4, 5, 6, 7, 8, 9, make my point. Okay, and then -1, +3, 0, +1. So then 1.3, remember we're just going to estimate that, and then 2.1, we're going to estimate that. Okay, so now that I have my points, let's go ahead and sketch our line. Okay, so in this one, it's starting up higher and then it's decreasing. So remember we said when it's decreasing, we're going to do exponential decay. Okay, so for this one, it is decay. Okay, so if you notice, when my function was a fraction, so 1/3 was a fraction, we have exponential decay. Okay, and then in my function, when I had a whole number like 3, we have exponential growth. All right, so now one you try problem, you're going to graph the function just like we did, and then I want you to state whether the function is exponential growth or decay.